Hello, my name is Hans B. Gonzalez.
My name is Eman J. Ramelo.
We're going to create a video about static from physics. This is our project for Sir Joe Maropatan, and this is some definition about statics.
Statics is a branch of mechanics that deals with the bodies at rest or bodies that producing equilibrium. The state when all the force acting on body are balanced.
Some example of our example and meaning of static. That is, guys, about the statics. And the next is the parts of statics. We have mass, weight, force, and density. And in mass, we sometimes it's all about the mass of the things, or sometimes in chemical. And in weight, weight is about gravitational force, the weight. But the mass is from mixing in the chemicals. And we have to show another definition of mass and weight and the difference and examples. Please.
What I have here is probably 100 grams. I say probably because although it says it on the mass here, it might be 99.5 or 102. I don't know until I maybe get some calibrated scales. However, if I take this up to the moon, it will still have a mass of 100 grams, and I take it out into deep space, away from the gravitational field of the Earth, it will still have a mass of 100 grams. And the word mass is effectively the amount of stuff within an object. What causes mass? We don't know, actually. Fairly simple questions, but this is where the Higgs field and the Higgs particle comes in. And there's a link in the video below to a couple of really good descriptions of what mass actually may be. So 100 kilograms is a fairly large mass, and it might perhaps be the mass of a spaceman. This includes all of their equipment and also the person themselves. Now, if we look at this spaceman on Earth, they're going to experience a force due to the gravitational field of the Earth's pull. And then we can also look at their weight. Now, the weight of an object is equal to the mass times the gravitational field strength. And on Earth, the strength of G is about 9.81. And because this is the force per unit mass, we can either measure it in newtons per kilogram, but this is also the acceleration due to gravity, and the units can also be meter second to the -2. Now, either of these sets of units are absolutely appropriate, and for most places on Earth, G is about 9.81. It does vary as you go up mountains and overseas and things.
That is about the mass and weight. This is and we have some parts of the next of the force.
Three types of based on point application. One, congruent force. 2. Parallel force. 3. Na planar force. Next is 2 types of resultant. Unopposed or unbalanced force. Yung pangalawa, unopposed or balanced force.
That is the other part of force, but we have more definition and example of force. And now that is the example. We have to show to you the example and definitions of force.
Force. We hear the usage of this term many times in our day-to-day life. We might not know that we're using it. Opening a door, riding a bicycle, lifting an object are few of the most common things that we perform in our daily lives, and all these require a force. What is a force? Consider a ball lying on the ground at rest. It's not moving. Suppose this player here wants to pass this ball to his teammate who's standing on the other side of the pitch. How will he do that? He needs to make this ball move in the direction of his teammate. So he will kick the ball in the direction of his teammate. When he kicks the ball, we say that he applied a force on the football. Yes, the kick is nothing but the force he applied on the ball. Now suppose that we have a desk here at point A. A person wants to move this desk from point A to this point B. Again, how will he do that? Here, he will push the desk towards point B. In this case, we say that the person applied a force on the desk in order to shift it. The push here is the force that the person applied on the desk. Similarly, when you lift some object from the table, we say that you applied a force on that object. Here, the force is applied in the form of lifting. So, forces are nothing but actions such as kicking, pushing, lifting, etc. performed on objects. There are many such actions that we can perform. We have already seen few of these. Some more of them are given below. While riding a bicycle, we pedal it continuously to keep it in motion. Here, pedaling is the force that we apply on a bicycle. Hitting the hammer on a nail is also a force applied on the nail. What about stopping a moving ball? Yes, even stopping the ball means we are applying a force on it. We applied some force to stop the ball. Opening a drawer, plucking the string of a guitar, moving a piece on a chessboard are some of the other actions performed on objects.
Hey guys, that is the meaning of the force in the example, and we have 6 kinds of force. The first is the weight force, the normal force, and the third is the friction force. And the fourth
is tension force. And the fifth, elastic force. And the last force is repulsive force.
And we have shown to you the meaning, the definition, and the example. That is it.
Ask anybody around you this simple question, what is gravity? And what you'd probably hear is, it's something that pulls objects towards the earth, or it's a force exerted by the earth to pull objects towards it. Now, before we get to the basics of gravitation, there is one thing I want you to understand well. Rather, there's one thing I want you to forget. Forget the fact that gravity has got to do only with the earth and the objects close to it. That's not gravity. We'd see examples where objects are falling to the ground and we assume that it's the only concept we need to know about gravity. Yes, of course, it's gravity that pulls the objects towards the earth, but that's not the only thing you need to understand about gravity. So what is gravity? Consider your screen to be the universe. And these are any 2 objects in the universe. They could be planets or humans or animals or whatever. Just that they both have non-zero mass. In this case, both objects are pulling the other object towards each other. This object is pulling this one towards itself, and the other object is pulling this one towards itself. This attractive force between any 2 masses in the universe is called the gravitational force. So the gravitational force is the attractive force between any two objects with non-zero mass separated by a distance.
Now we can consider the normal force. So our first question is, what do we mean by normal force? Let's start with one word at a time. Force, we've already talked about, is a push or pull on an object. So then we get to normal. Now what we don't mean by this is it's not an ordinary force. While they happen all the time, that's not the usage of the word normal we mean. Instead, we're talking about a mathematical definition of normal that refers to the perpendicular. So for example, if I have a surface, my normal force is always going to be at a 90-degree angle perpendicular straight out from that surface. And I use the F with a sub n as my symbol for it, both capital F and capital N. So here's some examples. Again, if I have a horizontal surface, my normal force might be straight up from that surface. If I have a vertical surface, my perpendicular is going to be, say, out to the left. And if I have a sloped surface, my normal force is still going to be perpendicular, but that means it's going to be off at an angle.
How do things move in real life? Say a ball is moving on a flat ground and there's no external force acting on it. Will the ball eventually come to a halt? Yes, it will. Have you ever wondered why? Say you're skating on an ice rink and your friend is skating on the road. Whose movement do you think will be smoother? Definitely yours. When you hold a bottle in your hand, why doesn't it just slip through and fall? Sometimes when you're walking around in a mall, do you remember seeing a caution sign to warn you about the floor being wet? What explains all this? The answer is friction. The reason why the ball eventually comes to a halt is because of the force of friction. The reason why skating on an ice rink is easier because the force of friction is lesser there. The bottle doesn't slip through because the force of friction between your hand and the bottle doesn't allow it to do so. If the floor is wet, the friction offered by it reduces and there are chances that you might slip and fall. So what is this friction we're talking about? It's quite easy to understand its concept. Friction is nothing but a force. It is the force exerted by a surface where an object moves across it.